Okay, so before we start, I'm Omri. If you haven't met me before, I'm the president of MonSec. Hi everybody. So what is good way to introduce? Okay, so who in here used the command line, like ever? Okay, good amount of people. Yeah. So do you find that? Do you find okay? How? By show of hands, how many of you find it easy? Okay, yeah, fair enough. I see. It makes sense. Yeah, because it's so I think today I'll show you like the background behind it, like where it came from, like the core standard of Unix, and maybe okay, so like about Linux, right? Who in here use Linux ever? Like, ooh, okay, good amount. So if you haven't used Linux like in person, like you probably used like something powered by it because it's powering everything, powering every server on the internet is like mostly Linux. Android is Linux. IoT is probably also Linux. So it's very common. And today we learn about the basics of how to interact with it, how to its caveats. Like we want to maybe like this will become useful once you get a shell into a system and you want to find something. So if you know how to work with the shell, it's very cool. So background. Okay, yeah. So I think Linux is influenced by the work of these two people. They're Ken Thompson and Dennis Ritchie. They invented two major things that are used pretty much ever today. Unix, the OS, it's like, and C, the programming language, and they got a Turing Award for different things. So they're pretty much like amazing, and they're okay. The reason why the Unix is so prolific is because AT&T, the company that owns the code for Unix, they sold it away, the code to unis, to businesses, and unis they pretty much taught that in their course as part of how to do of how to design an OS, and it's pretty much the main standard for how to make a good shell. OS they made their own fork, like their own version of that, based on the code that they bought. But the thing is, they left a lot of the code from AT&T in there, which led to a lawsuit, and that in turn it slowed down the development of their version, BSD. And if you use a Mac ever, Mac is based on BSD. So it's pretty much the same lineage as every as most of everything Unix, Linux, yeah. So now we're to this guy, which is I have a typo in his surname. Okay, never mind. He's kind of a genius, kind of a meme, to be honest, but he's very influential. He was a researcher in MIT, and his printer broke down, and he thought, wow, it's so bad, it sucks. So I want to make my own code for everything and make it public knowledge, and that became GNU. And GNU is so he pretty much remade Unix, like the core utils, the compiler, and the core blocks of the OS, except the kernel. And his work on the GPL, the general public license, influenced how we think of software that is critical and that is important. And this is how and the GPL is also the main essence of the kernel of Linux and many other things. And so the main piece, the last piece of the puzzle is Torvalds, that he made Linux initially in 1991, and he used the GPL as the license, and that is a very big decision because that license says that if you copy the code, you have to make it available for everybody. So that made it available as a Unix style kernel that is freely available without any copyright issues. And that's why pretty much everybody picks it up today, like Android, like I think Amazon, like every cloud provider is using his stuff. And yeah, so what is Linux? So Linux could be, you think about it as a distro, like this thing on the left. And it's pretty much just the kernel, right? Just the kernel, that's the part that able to interface between the hardware and the software. And we pretty much need other things like the GNU software, a desktop to make it usable. But today we learned just about the shell, the command line, and how it works. So you may have heard about a distro, like a distribution, which is like, it's going to be a community. It could be a company that they would package the kernel and the desktop and the apps together to one package that you can use for free or for money. And yeah, so I mean, like for example, Ubuntu, they care about ease of use, so they could just install it in like maybe 10 minutes and get it going. Or Arch, which is like Arch, like the blue one is like a meme because it's pretty hard to install, and they prioritize being able to change everything as you want. Or Debian and Red Hat, they pretty much prioritize stability. But we usually use Kali. Kali is like a distro that is used for security research and penetration testing, and it's really the main thing about it that it comes built in with like many tools to attack or to defend something. And one big caveat is that although these tools are free, if you do something, it won't make you a white hat hacker. Like so you have to apply ethics, right? So like any other tool. So I think here are some other resources, mainly memes, but I think you just take those in if you want. Yeah, so I think what we will use today, the main challenges is this URL right here, and we'll use SSH to connect to the machines. You should all have SSH, even on Windows, I believe. So let's start. So can everybody maybe go to that website and open a terminal on your computer? If you don't know how to, maybe ask one of us to help. So I already have the command in my history, but so we want to start with this command. And actually, let's open the website as well. So this website, so each level, they give you like a prompt for the level, like some instructions. And our goal is to find a password for the next level. So we don't have a password initially. We want to trick the OS to give us the password, which is stored on a file. So it's pretty much like a good challenge to maybe learn about the shell, command line interfaces, user permissions on Linux, because each user, they have their permissions. Is the user or the group. And yeah, I think also I have my notes here, so because I don't remember everything, but I'll give you my notes after the workshop. So for now, what you need to have is, so the password for the first level is just Bandit 0 for level 0. So just to get in, so let's Bandit 0. And yeah, okay. So we're logged in. If you can get to this stage, we ask us for help. And once you log in, you pretty much see this like guide that they made for you from over the wire. You can read it. It's like pretty good guide. It's like tell you about some online resources and how to find stuff. And they also have some built-in tools that aren't normally installed on a server, but they're installed on Kali, I believe. And we also have access to Python 2 and 3. So I think the first command we will use ls. ls is used to list files in the current directory or in any directory. And we have pretty much one file. Let's maybe, so normally ls would only list files which don't have a dot in the first character or their name. So let's maybe list everything, -a. Okay, we have some more files. We mainly care about the file called readme. So we want to print that to the console. Let's run cat for concatenate, I believe. And that's also one thing. If you use if your shell is interactive, you can also press tab to complete the file name. So if you want to type less, like me. And here's the password for the next challenge. Oh yeah, the -a flag is for to list every file on the directory. It's really useful if you want to find files that aren't really visible by default. There's also -l to list in a table. And also, I just want to point out this section here. So this will give you the permissions for each user. So it's like, so it goes like user, group, and everybody else. So, and so the user has read and write, the group has read, everybody else has read. So I think it will read, write, and X for execute to run code. And pretty much in Unix, like in everything, I mean, okay, not everything, but many things are actually a file. So like if you want to see, let's run which ls. So the binary for ls is stored at this path, and you actually run this like when you run ls like that, it will actually find this path on the file system and run this from that. And it's useful if you know that early on, because it will make life easier when you run other binaries that aren't on the main path variable. But yeah, also if you ever code like in, let's say, every good language, you will see you can like print stuff on the console. So behind the scene, the console that you print onto is also a file called ssd out or stnout out. And yeah, so I think we have the command, the password. Let's copy that. So we have that ready. And now we should, let's exit. And we want to log into level 1. So same command, but instead of bandit 0, bandit 1, and the password is the file we found before. Let's paste. Also in SSH, whenever you type a password, by default, you won't see it for security purposes. So if you don't see a password, it's fine. It's the point. Yeah, so now we are level 1. Let's, for good measure, let's look at the prompt for level 1. So, okay, our password is calling a file called readme stored in the home directory. Okay, actually, yeah, here's the caveat, right? The file is named dash. Why can anybody, okay, does anybody have an idea why that is an issue initially? Yeah? Yeah, I think also for me, I thought that it can also be like a flag as well. Yeah, so we can make that easier for us. So we can just, so you can very easily escape the current path onto. So I think we just go around it, but doing // and dash. I think that would work. Okay, to cut, my bad. Okay, yeah. So pretty much // is just like a shortcut to get the current path. So also, you could also do it in a different way by doing. So one more command is ptld to print the working directory. So this would print the current path to the console, and we can put that output into our prompt by doing that and that. So pretty much we can just like interpolate any command into any other command, and like, yeah, and do some more cool stuff. So here's the, so we can just, yeah, cat, my bad. So we want to print. So yeah, so we just as a caveat to what we can do in command line, we have to be aware, because like probably if you want to hide a file, dash isn't really a good option. Go to level 2, and let's use the password we found before. And yeah, okay. Let's get the prompt. Okay, yeah, level 2, 3. So, okay, now the file contains spaces. So if you run ls, we have, it's like normally when you run ls, if you have many files in one directory, you will have like some space or like tab in between them. But in this because the file has spaces in the file name, so it might be a bit tricky to, as a beginner, to get the file paths. What we can do is to maybe escape the characters. So to most commonly we use like a backslash to escape characters, so we can denote their other meaning, because a space can be to separate arguments, or it could be part of a string of a file name. So let's run cat to print. Now we can press tab. Okay, nothing is here. Okay, so if I just like type sp and tab, it would complete the rest of the file name. And by default, it puts the backslashes before each space, just to escape the string and to make it to make the shell figure out what it is. And yeah, very easy. So just, you probably go harder as we go on. Okay, this time the file is hidden, quotes. So it's not really hidden, it's just the default of the command ls is to show, if you do this, ls, okay, let's say ls in here. So ls can also have like another argument, which is the name, the path of the folder to list. So it's empty, seemingly. So let's try to, I think I show the -a flag. Yeah. So -a would list every file, even if it starts with a dot. And yeah, it's really useful. So like, I think if you want to customize your shell for your own system, you would use a dot file of a similar name, just a different location, different function. And there, once you dive deep into the settings for Linux, you will see the edit files everywhere. So yeah, let's cat in here. Okay, yeah. So in this level, the password is stored in a file that its format is so every other file is like there are many files here, I guess, and every other file is not a human, is not human, it's not human readable. I'm going to find which file it would be. So let's see. So we have a folder called in here, and we have about 8 files. Now I'm lazy, so I want to maybe try a script to find the file for me. So let's see. So I think, do any of you know about the pipes in Unix, or like pipes in a shell? So pipes are used to forward the output of one command to the input of a different command. So maybe something. Okay, I think. Fun thing. Maybe, okay, let's maybe, what's a good pipe? So actually, CD, oh yeah, of course, because I'm not in here. That's why. Do it again. Okay, yeah, okay. So initially I was in the right folder, so we have the output of ls is piped into grep, and we're going to find anything with the character 8. So we can use that on top of more commands. So actually, I want to see what commands they. Okay, find. Yeah, okay. So find is a good one to use if you want to search for files based on their file name, but based on their size. So we want to pretty much in each file, if we want to run a command called file. So actually, let's see if we run a command called file on, let's say, I don't know, 1. Oh yeah, okay, because of the yeah. So if we actually let's do it. Let's print it. Let's print. Okay, it will be junk because we don't. It's not a human readable. So we want to find which file is human readable. So we can do it efficient in a I guess lazy or automated way would be to run. So find and so find on the current directory. If you are not here, I could put the folder name, and the type would be file. And then we want to run a command. So we want to run the file command on the input. And then we want to terminate that, and then we want to pipe that into grep. And we want to pretty much search for ASCII text. Okay, so I don't expect anybody to. I don't expect anybody to know that from their head because it's pretty annoying to type, but it's pretty powerful to know. So for each file on the file system, we like in this folder we search it and we run a command.
The easiest way to do it is to do file / and then the star sign, and it'll just print out the file information of everything, and the one that's the ASCII text.
But what if you have more files?
Like true. I was mentioning the way that I did it, it's a bit easier.
Yeah, so I think I think so. You could also do this. You can also do file star. So for like a pattern. Oh yeah, because we have the. So this would run the file command on every file in the folder, or if you had more folders inside, it would run on everything. This would work if you have less files than like if we had like more files than we can see in one frame of the screen. We need to run this, and so this will just find like run this command on every file, then pipe the output to grep, and actually we probably just do this. Probably just yeah, same thing I guess. But I mean, I think find would maybe be more fine-grained because like it's gonna only it will give you only files, and yeah. But I mean, both ways can work. So we want. I think it's probably file 7 because it looks very like it's only ASCII. File 7, and here we go. Yeah. So it also must be immutable, but it also must be a size that we want. So we can do very similar thing to the things we did before, but so we want let's ls. Yeah, now we have more files, so it's a bit more tricky. Okay, those are folders. So we have. Do we have 3? Okay, never mind. So tree would just give me like the tree graphics of the folders, but never mind. So we have like more folders in the folder, so it would take more time to find. But we can use the find command on the in here folder. Just to have the slash in the end, and so sending we want a type of file. Now we want the size. Okay, now you really wonder how to find all of these flags and arguments. One option to Google it as you go. Everybody at some point they have to Google stuff. They also have links to the. So here's the. So this is the manual page for find. Everything they have, I mean, it's pretty long, so people have to Control F to find what you want. So they describe everything in here. It's also available as a in here as well. So like to find the manual, so scroll, and probably better to do it on your browser because it's easy to search. Yeah, but anyhow, find in here. Want a type, and we want the. That was a bit weird, so I know why it's C in the end, but apparently because that would mean bytes to the find command. And we also want to run the file command on every input. So I think this slash and semicolon would pretty much mean like, so this would escape the command for find for the, because like you have two commands in one. It's a bit annoying to figure out, but like that would escape the command, so only find, so find knows what to stop, but also for the pipe to know what to process. And yeah, so we found, so apparently it was 2-level zip. Let's just copy that. Oh yeah, okay. So I think I know why it like messed up my shell, because it's like, I think all of that is like a spaces, apparently. But we care about that. Okay, now it's getting more interesting. So same thing, but now we have the concept of a user and a group. So in Unix, each user, when you make it one, it has its own user and also its own group. And it is for like when you share a machine with like more people, so can define permissions for your friends, for you, and whether it be to write files, to read files, to run code on your home on your home directory. So now we want to find files based on those things. So we want to find a file that is owned by Bandit 7, by the group Bandit 6, and be this size. So yeah. Okay, now it's not. We don't have. Yeah, those are files for the shell, for Bash as our shell. We don't have anything in our home directory. We have to find to use the find command. So now, instead of finding in the current directory, let's find in everywhere. So slash is the root of the file system. So let's find everything on the drive. So we want user Bandit 7. And group of Bandit 6. And size, this was 33. Now, if we run that, actually, let's run this. We get this mass because we don't have really access to those folders because we aren't really the admin. So what we can do, we can. So I think, like I said, that in Unix everything is a file. So there's also a file for the garbage, like called null. And so we can just say 2. So I think 2 means like in every error we like everything in std err, like anything in the as an error, we forward to device called null. Now, yeah, here we go. Now we got to one output. So it gets the password. So it's in a file, but it's in a very. I mean, that file can be very big. Let's see. Yeah. Okay. So here's the file. Let's maybe. Also, by the way, so although you think it is a text file in Unix, and I mean in probably every OS, that is like the file type in the end means nothing. Like it can be any name. Like it can be a JPEG for like I care, but in this case it's a text file. So I think it might be very big. Let's so it is 4 megabytes in size. So let's start with the grep because we want to search for the word millions, I believe. So let's say, oh no. Copy. Ooh, okay, easy. I thought it would be a bit harder.